Okay, my friends, I just want to start off by saying that I'm finally starting to make some inroads. I just got this from Academia EDU, which is where I post some papers. Long ago I did. I haven't posted for years up there, but they're starting to look at it. Introduction to Mudfossils and Geology was your top paper last week. This just came in yesterday. Now, they're starting to look, but all of a sudden I find out that there's pushback from the people that we expected to be the scientists. And here I'm going to show you who I'm talking about right now. But I'm hoping that we can get past these people that are stuck in the mud. Okay, and I'm going to try to be respectful. I understand people have an opinion and they want to stand by that because it shows that they're made the right choices and decisions. But in this case, they're not right and they need to be reassessed. And that's what she says she is all about, is being contacted to make determinations. Basically, that's what I heard from her, that she is the one that can make these determinations, and she's determined that people like me shouldn't be allowed to do the research we're doing, basically, which is kind of upsetting to me, but I'm going to try to be nice. Now listen to what she has to say. It's Sabine Hossenfelder, and she's a scientist and a physicist, and let's see what she has to say. She was contacted by a magazine to put an editorial piece in there about what's the story with physics. Are these people getting out of control? Because they finally started to listen to me. So now they're out of control. Well, let's see what she has to say about it, because that's what she says. We're just crazy people doing crazy things, wasting people's time. It's basically what I got out of her. Now you tell me if I'm wrong. Here we go.
I was contacted by an editor of Physics magazine. That's an online journal of the APS, the American Physical Society. He asked if I'd be willing to write an opinion piece about whether some topics in physics are too speculative to be legitimate research. He also suggested some topics to consider, for example, string theory, and Avi Loeb's claim that the interstellar object Oumuamua was alien technology. I thought, I'm exactly the right person for this, and you know me, I wrote an honest opinion piece.
No, she says she's exactly the right person for this. Excellent. That's what I want to hear, because I want the right person to make a determination about the things that I present. And that's exactly what she says she's willing to do. Let's hear it from herself.
But when I was done, another editor popped up to say, I paraphrase, that was a little too honest, and they wouldn't run it because it might offend some of their readers. And I said to myself, you know what, I think my subscribers on YouTube will appreciate some honesty. Can physics be too speculative?
All right, so we appreciate honesty? I do. Can physics be too speculative? Well, possibly. When they start talking about wormholes and all kinds of things that they have absolutely no support for, yes. That's fine. You can talk about them. I'm not going to say don't waste your time. That's what she's saying. Don't waste your time talking to things that Roger talks about.
That's what we'll talk about today. Imagination and creativity are the heart of science. But if you look at the headlines in the popular science media, you can't shake off the feeling that some physicists have gotten ahead of themselves.
All right. When she says they've gotten ahead of themselves, she's going to explain that they're just talking about nonsense because they have no support whatsoever to back up the things they're talking about. Dark matter, string theory, fifth forces, multiverses, mud fossils.
There's multiverses, dark matter, string theory, fifth forces, and that asteroid, which was supposedly alien technology. These ideas make headlines. But then you never hear of them again, like hundreds of hypothetical particles that...
Well, let me tell you something, Sabine. I have been posting my stuff for 10 years, and I never hear from you. And I've been posting, I have 2,000 videos that support the things that I'm saying. I have stuff to cover. Every single bit of the things that you're saying are nonsense. So I expect to hear from you, my friend.
were never detected, and tests of string theory that were impossible in the first place.
No, it's not impossible. See, that's what she says. This is impossible, so why should they bother testing it?
Or they later turn out to be wrong. All reports of fifth forces disappeared, and that asteroid?
Fifth force is disappearing. Well, those are the muons. I can show you they do disappear. That's correct. But you have to look at them before they disappear.
Was probably a big chunk of nitrogen. I've talked about each of these topics.
She's talking about Oumuamua being the asteroid that she's saying is just a big chunk of dirt or nitrogen or who knows what it is. I know exactly what it is, and I will show you exactly what it is. And I will start with Comet 67P just to start at the most incredible place, because that is biology.
Previously, so today I want to look at the big picture. Is all this speculation good for something? Is it normal science, or is it in the way of progress?
Is it in the way of progress? Should we just stop this and not listen to Roger whatsoever, because he's just an insane person. He's been going insane for the last 10 years. We've tried to avoid him, but now they have stopped trying to avoid me. And she is trying to pull the plug on my science.
The question, how much speculation is healthy, differs from the question where to draw the line between science and pseudoscience. That's because physicists usually justify their speculations as work in progress, so they don't have to live up to the standard we expect for fully developed scientific theories.
I have fully developed scientific theories, and they are backed by scientific evidence that is undisputable, unimpeachable, undeniable, and magnificently displayed in my Mudfossils and all of the other work that I do. I present nothing, zero, that has no support. Everything I present has something to be discussed, and discussion is not in their itinerary. They just don't discuss things that they don't want to discuss. And I'd be very surprised if I hear from her. I've already sent messages to her that she's got a little issue to deal with here, and let's see if I ever hear back. But so far, not one has responded. Zero. Let's see if she's different. She's talking a good game.
It's then not as easy as pointing out that string theory is for practical purposes untestable.
No, it's not. None of these things are untestable. They're unallowed. They're not allowed.
Because its supporters will argue that maybe one day they'll figure out how to test it.
Yeah, I have figured it out, and nobody will pay any attention.
The same argument can be made about the hypothetical particles that make up dark matter.
I have shown dark matter, and I will show them to you again, Sabine, and no one will listen.
Or those fifth forces. Maybe one day they'll find a way to test them. So just looking at testability doesn't help. The question we're facing is more similar to the one that the philosopher Lakatos posed. Which research programs make progress and which have become degenerative?
All right, see, she's talking about me as a degenerate. And that's my whole resume, is this guy is nothing but a fool, a degenerate. Stay away from him. If you talk to Roger, you're in the same stupid, foolish place that he is. So stay away from him. Don't listen to him. Don't respond. Otherwise, you get trapped in reality.
When speculation stimulates progress, it benefits science. But when speculation doesn't improve our descriptions of nature, it eats up time and resources and gets in the way of progress. So there's no one-size-fits-all answer to the question what speculation is healthy. We have to make this...
All right, speculation. Speculation is something that has absolutely no evidence to support it, which is like, wormholes and all these absolute nonsense things that they talk about. Yes, absolutely. There's crazy people, yes. That's okay. Let them be crazy. Because someday those crazy people may come up with something that supports that crazy assertion. Just like I did. I didn't make the assertions first. I came up with the evidence first, and then I made the assertion. The only assertion I made ahead of having any evidence was 50 years ago. I said there is no such thing as a single-sided polarity. There is no negative electron that has no other... everything has to be a dipole. Let's just cut to the chase. And I said that to my professor. I said, this is impossible. This Bohr theory is just nonsense. Absolute nonsense. And he wanted, and I had an A going into that last statement, and we almost had a fist fight because he says, no, you're going to get a B because you didn't pick up on the correct take. And I said, no, you didn't pick up on a correct take. And I ended up getting my A because I forced him to go against me in a competition, and he lost. And then I got my A. And so I never back down. I will never back down from anybody about anything that I have evidence. And at that time I didn't have evidence, but it was so obvious that, you know, I knew much more than he did, way more than he did. He had no clue whatsoever compared to what I was doing. So he was just lost, and he had to admit it. But I didn't have the evidence that I could stand up. Now I have the evidence, because from the light research, I can actually show you the particles that she's saying don't exist. And all of the things she's saying don't exist, I have absolute 100% solid, rock solid proof.
Assessment on a case-by-case basis.
Yeah, case by case.
Let's then look at some of those cases, starting with dark matter.
All right, let's do that. Let's start with dark matter. Okay, so let's talk about dark matter. This is from CERN. Dark matter is invisible. Dark matter makes up most of the universe, but we can only detect it from its gravitational effects. In other words, it pulls the white matter into it. That is what dark matter, it sucks white matter into it. So let's see if we can find some dark matter. All right, here's the whole key, and I'll show you dark matter uno momento. Dark matter, unlike normal matter, which glows and excites and radiates back light when it's focused on. Dark matter does not interact with any electromagnetic force. It does not interact. That means it does not absorb light, it does not reflect or emit light, it does not do anything other than attract, making it extremely hard to spot. In fact, researchers have been able to infer the existence of dark matter only from the gravitational effect, the extraction effect it seems to have on normal visible matter. Now, I'm going to show you both of those things right now, because we've seen them. I can produce dark matter very easily. And you say, oh, Roger, let's see the dark matter. Well, see those little black balls right there? You see those little black balls right there? You see that white spray? The black balls are dark matter. This is the white matter that we know about. This is reflective, emitting light. This is light that will emit, it will absorb, it will do everything energetic, which you can see extremely energetic. This is nothing. The black ball does nothing. Where did the black ball come from? I'll show you where it came from. It came directly from laser light. That means we shot a laser, pulsed, This is the photon. That is the particle. The black spot is dark matter. It is dark matter. The white parts are the electron, which is the explosive portion. The black is sucking that white back into it as hard as it can, because the black is gravity. That's why we can only see that black, due to its attraction of the white. And here's what happened. We shot that particle, which is all that four little box like this, and accelerated it. Yes, you can accelerate light. Einstein was wrong. Bohr was wrong. So they were all wrong because they didn't understand electron flood theory, which means there is nothing but electrons. And I will fully illuminate electron flood theory. So here's the particle. So you have a particle way back here creating a magnetic field in front of it, so you have particle wave. The two of them work together coming through. As soon as they approach the Venturi, the thing just goes zip, just like a rocket ship. For some reason, and I haven't quite figured it out yet, but the black particles now, which were attached back here, separate, and they go around and just get out of the way, and a white explodes. Identical to what CERN is looking for. They call it muons and electron showers. And don't forget, that's the Venturi. These are the muons. These are the electron showers. Let's take a look at that. All right, we're going to go up to here, and we're going to see this is exactly what CERN is looking for. Muons and electron showers. The two white and the black balls are attached together. When they concuss, the muon goes on its way, just it has nothing to do with the white particle. The white particle turns into a shower as it concusses, and then they recombine almost instantly, as I just showed. So that's pretty obvious that CERN and I are looking at the same particles, except I see them and they can't. They have a little cartoon. I have the actual picture. Now this is a little enhancement of that particle, but here is the dark matter. This is nothing but attraction to white. It will pull that back into it instantaneously. They will never be separated, except for when we put them through the Venturi. CERN has seen these particles. They just have no clue where they came from. They saw them because they're hitting billions of particles together, literally billions. And then they're digging through the debris and they're seeing little bits and pieces, and they just say, wow, look at that. Isn't that interesting? But we have no clue where it came from. We started with light, okay? This is laser light. Light is light. And when it comes out, and we separate it, we can actually see the particles. And then when we put it through the Venturi, this is just before it concusses. And that's the only time you see this arrangement. Just before it concusses, it displays. And then as it concusses, it separates. As you have seen, the white showers through the Venturi, the black goes around and outside. This is the enhanced version. The forward-leading white particle will be more enhanced than the back one. It will wobble, it will spin, it will do all those things as it concusses going forward with the particles that are in the air, because the particles in the air have the same properties as light. They have a positive and negative all over the place. So as this negative, which we call the electron, bashes into another electron somewhere in the surrounding environment that it's passing through, it wobbles, it bangs, it pushes. It's always push to shove. If that pushes against another white particle, it's push to shove. One's got to get out of the way, one's going to bounce, one's going to spin, whatever they do. And they appear to right-hand spin, and it has something to do with the way that box bangs into the forward one, and they start to spin and create this vortex-looking thing with spikes coming to top and bottom. Very interesting stuff. But Sabine, I'm showing you dark matter. So that's the start of where we're going to go, because everything you said, I can produce evidence to support the facts. And it's not silly. It's not something you should walk away from and say, don't follow this guy, don't listen to this guy, which has happened to me for 10 years. Because everything I'm showing, this was 5 years ago. This whole thing, light is dark matter, hold on. Maybe I did this just recently. I can't remember. But I have been showing this for 6 or 7 years. 6 years ago, I showed light is dark matter on its way to the Earth. And that is what it is. Because this doesn't concuss normally in coming through the atmosphere of space. These do not really glow brilliantly because they're not bashing hard, because there's just so much stuff that's random out there. It's not like hitting a wall like it is down here. In the gases of the Earth, you think if it's just air, there's just nothing there. Oh, no, 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 no. This is a solid mass of particles that I'm waving my hand through. It's almost solid. It gets out of the way, but there is so much density here on the closer to the Earth that the particles are just stacked right up on top of each other. When you get out into outer space, and I watch the Russians, I have a video about the Russians in space. You just look at a plasma in space by the Russians, and you will see what plasma does in space. And these particles create, unbelievably, they create a black hole. I'm not kidding you. They put the black material in the center and surround it by white material. And that's what happens in outer space. We can't do this here on Earth because everything is flat like a pancake. Nobody has any concept of this yet. They just don't understand the nature of particles yet. Physics is really broken in every single way. The nature of the nucleus is dipole. It's not a big giant positive and a couple of little negatives floating around. Absolutely not. All right, this is a good time to show the new model. The Bohr model's gone. It didn't work, never worked. I proved this, well, I didn't prove it, but I demonstrated it 50 years ago. You can't have a non-dipole nucleus. Impossible. The nucleus is made of electrons, which we have just seen are polar. They have a muon dark matter portion nobody's ever seen before until we put them through the Venturi and separated them. So now we know we have a muon and we have an electron, two different components of the electron, which we always thought was just a negative. No, it's a positive and a negative, and the positive is dark matter, and it only shows up when you put it into this extreme condition where it's concussing through a Venturi. The photon, as I just showed you, is the box of particles back to back. Protons are 1,839 of these electrons in a ball. And the dark matter goes to the center, and it's surrounded by a ball of electrons on the outside, because those are the ones who want to get away from each other. So they push the dark matter to the center. The dark matter doesn't mind being on top of each other. You could have dark matter on top of dark matter. Couldn't care less. But the white will never, ever, 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 ever get next to each other. It will always push away. It's called the Casimir effect. If you try to push one particle of anything, no matter what it is, against another particle of anything, I don't care no matter what it is, they will push away. It's called the Casimir effect. Something that maybe we should take a look at now. All right, here it is right here, the Casimir effect. This goes way back. They knew about this long ago. And they call it a force from nothing. Well, it's not a force from nothing. It's a force from two magnetic fields opposing each other. And every single thing there is coated with electrons. There is nothing that has a surface that is not 100% coated with electrons. That means anything else that comes next to it has also 100% electrons. Electron to electron will push away. That's what the Casimir effect is. It says the attractive force between two surfaces in a vacuum, first predicted by Hendrik Casimir over 50 years ago, could affect everything from micro machines to the unified theories of nature. Now, here is all it is. It's just you take two materials and you push them close together, they push apart. Just you push these together, when they get close enough, but they have to become within a couple of angstrom units. Angstrom units are extremely tiny distances, and when they come together, they will just naturally push each other apart, like two magnets. That is exactly what you see there. That's the Casimir effect, and that is what is the basis of magnetic properties of particles. They push each other away. It's push to shove is what I call it. And every particle pushes every other particle away, and every other particle shoves back. Push to shove. There it is right there. All right, let's just go through it one more time so we don't miss anything. That's the pulsed red laser, and the field precedes the particle way back here. So you have a particle with the wave in front of it. The wave pushes against, just as I told you, the Casimir effect. This is nothing more than electrons, which are negative particles. They push against all the other negative particles that are in the gases that are in the air you never knew about. They're also negative particles. So you have a push to shove. These start to glow. This glows intensely because this is the hard pusher. Now, we know that this was the particles, the black and white particles, which was in this wave way back in the beginning of the wave. A particle back here, wave out here. Now we're seeing that particle I just showed you down below accelerate. And no question it's pulling itself out of the wave. You can see the wave is trying to catch up to the particle. The particle exceeds the wave, and at that point it is so powerful that it explodes at the venturi, separating the black from the white. And apparently what they claim is the increased energy value from here to there is 200 times. That means we put a 1 volt in here. We got 200 volts out. Let's just talk about it in terms of volts. That leaves us 199 volts of extra energy. We could have free energy tomorrow. This device could be designed, built, and on the shelves within a month. That's how easy this is and how avoided this has been. I showed this 6 years ago, not a single word, because of people like Sabine. Now this is Higgs fields on steroids. They say you can't see these particles. Oh, they're too small to see. No, they're not. It's just like an atomic bomb. If you took an atomic bomb that was not exploding and it was 100 miles away, you wouldn't see it. There's no way you could see it. And when it went off, there's no way you wouldn't see it. And that's exactly what we have here. We have atomic, really literally atomic fission, photonic atomic fission on a tabletop, viewed with a cell phone, because of the radiant intensity of the particles. Not because we're looking so small. The particle is so small down here, you really can't see it. You're never going to see the particle. You're seeing the radiant field. That's why these people can't, oh, you can't see a particle, you can't see that, you're just crazy. No, I'm not. You're the ones that are the ones that need to stop and to stand back and really pay attention. And this is what happens, is you get people like Sabine, so don't look at that stuff, the guy's crazy. That's happened to me for 10 years. I'm basically fed up with it. All right, you see that? That's light spins. Light is a spinning particle. Okay, it's a particle right there, which is the magnetic, positive and negative. It spins. This is a photon. It spins, and this is a single slit. This is not a double slit. There's no flapping this way and that way. This is a single slit, and as it screws through that slit, and you can see it's literally a drill bit. It's screwing through that slit, and when it does, the white particles want to stay away from each other, so they create these separation lines, which they call interference patterns. Those are push-to-shove patterns. Every white particle coming through here says, anybody to the right of me, get over there. Anybody to the left, get over there. And they say the same thing, so they spread out into these patterns. Most of the spin will end up going through the center, but some will spin off to this way, some will spin off to that way, and some will spin right directly in the center from both sides. So you end up with this spinning circular pattern of light. Also totally not understood. Okay, this is the progression of the decay of the particle into photonic fission, which happens right there. So what did we have? We had light coming in, which has no, you really don't see any discrimination about the light. This is just as they're starting to really compress. And the first thing you see is like a little Oreo looking cookie thing with a dark and a white in the middle. You can see that and you say, ooh, that's interesting. Then I see this and I say, ooh, what happened there? Well, they're starting to crush themselves because they're stacking up at the venturi. And as they crush, the white particles and the black particles display this box-looking form. I mean, it's just, you can see it. I'm not making this up. And this was taken with a cell phone because at this point they're starting to really become radiant and intensity. The intensity keeps getting more and more intense, and at the venturi it's just out of control, and that is when these particles separate. And this is the separation at the venturi. Now the green do exactly the same thing. It's exactly the same particle, only it's much more powerful. And I believe it's strictly due to the spin. The faster they spin, in other words, if you had the green particle, all right, the red particle. Let's take the red particle. Here it's coming through the air. Spin, 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 nice and freely. Now, when you take a green, you're down in this spin. It's coming through the air. It's the rotational value of the particle smashing all the way around itself into other particles that force it to turn into a circular spinning pattern. And the green is just much more radiant to begin with. It's much more impactful, and therefore it takes longer to slow down as it impacts. And I can show you that because we shot them through the same time, red and green, and here's what happened. All right, here's the particles again. They're still there, but here's what happens. The green comes through and the red comes through, same time. The green is so powerful, it just pushes the red out of the way. Get the hell out of the way. It pushes them down, and it comes through here, and it concusses in this area where there's a lot of interaction. Everybody's got a little bit of a glow, so that really bangs into it, pushes them out of the way, and then it reconcusses way out here. The red is gone, is completely gone at this point. The green still has extreme amounts of concussive value, as you can see. So that's the difference between red, green, and then blue would be even more. Blue, we really can't see these particles really in their box-looking form. I can't see them. We haven't done much with blue. Red and green, very easy to see. The blue is a little more, well, here I have one shot of the blue. Hold on. What we got here? Blue. Well, here I can show you down here. This is what happens with the blue. You can see it coming through. It's accelerated. And you can see the particle is long. It's like split, but it's just too glowy to see the dark, is my point. That's what I'm thinking. And as it slows down, it just sort of flattens up a little bit and it slows down. So light can obviously exceed the speed of light, no question whatsoever. If this was light And light is supposed to travel at an exact speed, which it doesn't. And that is accelerated light, which is obviously Einstein was wrong. This is the Higgs fields, and we have Higgs fields coming out of our ears. And between here and the Higgs is the electron showers. And right in this area, we can harvest raw electron energy. This energy right here is from the Venturi, which is way back here. And from here to here, it's 100% electrons. No dark matter whatsoever. That means it's 200 times more powerful than when it's attached back to its dark matter, which is back here. And just to be sure that you don't miss that, let's just look at it one more time. Here's when it comes through the Venturi. The blacks said, get out of the way, just get out of the way, go away. So they say right now, 85% of the universe is made of dark matter. And I can fully understand why. Because the white ones never want to be close to each other. The black ones have no compulsion about being close to each other. So as the whites stay away from each other, the black ones fill in all around it. So instead of having one white one and one black one, it'll have one white one and then 20 black ones laying around it somewhere that would want to get into that white one. And the white one wants to get into the black one, but the white ones want to push every other white one away, so they leave holes that the black ones fill in, and they more holes than you would expect. It's not one for one. All right, let's just put it to that point. It's one here, and then one here, and then one here, and then it fills in the black ones all around wherever there's holes between the white ones. And there's going to be a lot of holes between the white ones, and the black ones, like I said, they don't care. They'll lay right on top of each other. See it? They don't care at all. They don't care at all about being right on top of each other. But they seriously want to come back to that white one right there. That is the demarcation line. Right there is free energy, 200 times what we had back here. That means we got 199 extra energetic units. Why can't we use that? And I mean, I have already the design all figured out how to do this. Not hard at all. And you can put this in a box the size of a shoebox and run your house easily. Okay, so back to Sabine. On a case-by-case basis, that was starting with dark matter. So we did that. Let's see what she has to say.
The original idea of dark matter was a simple parametrization that fit a lot of observations. It was a paradigmatic example of a good scientific hypothesis. However, dark matter has trouble with more recent observations, and physicists in the area have taken on to accommodating data. That means they modify the model after they've seen the data, rather than making successful predictions.
Let me just make a statement. They made predictions long ago. I fulfilled those predictions. I went to the University of Geneva for particle physics, and I showed them this 7 years ago. And they were very impressed with my work, and they said they would follow me on YouTube and Facebook, which apparently they did, because they have modified their model to fit my physical evidence, which I showed them. They knew it. They said nobody fought back against it. They said, wow, this is very interesting. We will follow you. And that is exactly what they said to me from the University of Geneva. And they obviously did, because now, just like she's saying, oh, no, they're just changing their story. Well, obviously, because they are not like you, Sabine. They are looking at the evidence.
Moreover, all those specific particle models for dark matter that physicists have put forward are unnecessary to explain existing observations.
No, they are necessary. Existing observations, which you will not look at, prove that dark matter does exist, and it does exist in a form that you have never seen before.
They're just adding superfluous details. These models produce publications, but they do not further progress. That we're not making progress with inventing all those new particles is unsurprising, because guessing a specific particle from unspecific observations of its gravitational pull has an infinitesimal chance of working.
It has no chance whatsoever working, because you won't look at it.
So, lots of speculation that doesn't lead to anything. Particle dark matter is clearly a degenerative research
Yeah, don't look at it. It's degenerative. I'm a degenerate.
program. Theories for the early universe of fifth forces for dark energy suffer from a similar problem. They do not explain any existing observations.
Yes, I have just explained every existing observation, and the fifth force is plasma, and I have seen plasma in space, and I understand exactly how it works. The guy from Max Planck locked himself in his room for 3 weeks because he couldn't figure out what he was seeing. And I understand it because of electron flood theory. The dark matter collects in the center and the white matter surrounds it, and it blew their mind because this was out in space. You can't do it here on Earth because of the stacking of the gravitational pull. But in outer space, everything sort of drifts away from each other so that it can find its own place basically freely in a vacuum. However, this is something that I'm sure she would never look at.
Instead, they make the existing theories more complicated without solving any problem. Again, this isn't healthy speculation, it's a waste of time.
You are a waste of time, Sabine. I'm sorry. I like you. You're attractive. I like the accent. I mean, all that stuff is wonderful. But until you look at what is presented, then it's a waste of time thinking that you've already discovered everything there is to discover, and don't listen to anything that Roger has to say, even though I can present the evidence. This is my real rub. If I had no evidence, like you, I would say, yeah, this is a waste of time. But when I presented evidence 6, 7 years ago, and not a single person on the face of the planet will give me a minute to speak in the realm that you speak in, then I see that as basically fraud and just people that are completely incompetent. Now, if that's not the case, I would like to interact. And I don't think you're incompetent. I think you have just been misled. So if you have not been misled and you think you have the answers that override my evidence, let's discuss it. Because when I show you the rest of my evidence, you're just going to have to hit the floor, my friend. Everything you have said is wrong. Everything. Not a single word you have said is correct. So until you address me, then it's just we're walking around in circles paying attention to absolute nonsense. And that is where I say this is a waste of time. What you're doing is a waste of time, saying don't look at this, don't look at that. Very, very distressing to see this kind of an attitude in science.
It's a strategy that has almost zero chance of working, and it does, as a matter of fact, not work. You don't actually need me to point this out, just think about all the wild ideas that you read about that never seem to pan out. This, too, is clearly a degenerative research program. String theory is a different case. That's because string theory is supposed to remove an inconsistency in the foundations of physics. That's the missing quantization of gravity. If successful, that would be progress in and by itself, even if it doesn't result in testable predictions. Now, string theorists have pretty much given up on their original goal and never satisfactorily showed the theory solves the problem to begin with.
All right, string theory was nothing more than the nucleus and the electrons in their orbits being held by little, basically, strings. Well, it's actually not that far from wrong. They are being held by magnetic fields of influence. The dark matter that is surrounded by the white matter is attractively pulling more white matter in to the nucleus, which is over unity than the white. So the dark matter in the center wants more and more and more white. But as soon as it gets to a point where there's enough white surrounding the dark matter, the more white that wants to come in says, no, you cannot come in. I know you want to come in, and I know you would get in here if I'd let you in, but I'm not letting you in. You have to stay 2 angstrom units away. That's where you would create the orbitals. And that's basically a string. It says, I'm going to hold you on a string, but it's only a magnetic field. So string theory is not that far wrong, Sabine.
You might find that disappointing, but that's how science goes. It doesn't always work out the way you want it to. Much of what goes as string theory today has indeed nothing to do with the original idea of a theory of everything. Instead, string theorists apply certain limits of their theory in an attempt to describe condensed matter systems. Now, in my opinion,
All right, condensed matter systems. What is a condensed matter system? In outer space, we think it's a vacuum. It's not a vacuum. Absolutely 100% not a vacuum. It is completely saturated with light particles that are coming. I showed you they're particles. So don't tell me light is not a particle. If it is a particle and it's coming from the sun, the whole universe is saturated with light coming from every luminous body. No question whatsoever at this point. So what are we scrubbing through in space? We're scrubbing through that ether. The planet we are on is spinning through that ether in space, scrubbing. Our atmosphere on the outside is scrubbing through that atmosphere, which is an atmosphere. It is not a vacuum, creating extreme amounts of energetic reaction on our outer atmospheric surrounding, which is creating the heat that is heating our globe. Not heat coming from the ground up, it's heat coming from the up down, which is 2,700 degrees or more at the outside edge of our planetary atmosphere, and it's radiating down. And it's pushing down because we're pushing against the electrons. It's push to shove. It's the Casimir effect. We push, it pushes back. That creates heat. That is our problem. It's not carbon dioxide not letting the electrons flow away, which they just love to run out into space. No, they're being pushed into the Earth. Let's take a look at that, Sabine. I'm afraid Sabine has no clue about why the Earth is even warming up. If she thinks that this vacuum is in space, it is not. It's all completely saturated with particles. Our particles that are basically semi-attached to the surface of the Earth. They're attracted by gravity. They're being pulled down, but there's still a ton of atmosphere out here surrounding us. And as we burn things and do all the things we do, breaking big things into gases, we keep expanding our envelope. That means we push harder and harder at the non-vacuum of space that's pushing against us. That creates this rub. That's why during the day you got a ton of particles coming through here. But even at night, when you're in the darkness, there's still a ton of these particles. They're just floating around out there. They're everywhere. So we're scrubbing everywhere. The night, it just becomes a lot less heated because we're in a less extreme compression area. Here's the extreme compression, and that's why we got so much heat during the day. But at night, you no longer have that direct radiation, but you still have a scrub. So we will never be able to unscrub from the universe. The only chance we have to save the Earth is to stop this envelope from expanding. Every time we burn something, more and more particles go into the air. That means more and more electrons push more and more out harder and harder. And that is what's overheating, causing all this turmoil, all these huge floods and rains and tornadoes and storms and lightning. All of that stuff is interaction of our atmosphere with the atmosphere of space. Not a vacuum, an atmosphere. Okay, so now we're back to Sabine. Let's see what she has to say now.
String theorists vastly overstate the success of this method, but the research program is progressing and working towards empirical predictions. I'd say it's overhyped, but it isn't degenerative. What's with the multiverse? Multiverse research begins with postulating the existence of entities that are unobservable in principle. This isn't just degenerative science, it's unscientific. The origin of the problem seems to be that many physicists are Platonists. They believe that their math is real, rather than just a description of reality. But Plato...
All right, the math, this is where I always get in trouble. Where's your paper? Where's your math? Where's the calculations? Where's the equations? I said, I don't need that. I'm showing you the proof of what we're looking at. We'll figure that stuff out later. That's just nonsense. If you're just showing me a bunch of little doodles, I made all those doodles myself. I got doodles coming out of my ears, and it showed me that nothing was right. You want to see some doodles? I'll show you doodles.
Platonism is a philosophy and shouldn't be mistaken for science.
She's right. It is a philosophy. It's a bunch of doodles that they wrote out, and Einstein and all the rest of them, Bohr and Hubble and all of them, that made no sense whatsoever because they were just nothing more than doodles. All right, this is 50 years ago. You want to see doodles? I got doodles coming out of my ears. This was my final paper on bonding and non-bonding and the Coulombic molecular forces that created dipoles in the nucleus. I have doodles I can show you for days on end. I did everything they wanted to have done, and I proved, literally proved, that basically everything they were saying was wrong. And I had to fight tooth and nail to be, I was never accepted, and I never will be accepted, I'm sure. But this is all the little doodles I did. I could doodle until the day ends, till the year ends, till the month ends, till the end of time. I have doodles coming forever. Not a single one of them made any sense, and nobody would stand up and listen to a word I had to say. I even had to basically almost had a fist fight with my professor, and I destroyed him because he had no idea what he was doing. I still got my A, but it still was just an exercise in futility. And at this point, they're starting to come around and listen. That's why she's so upset. Because, you see all these crazy things these people are talking about? Wait till she talks about Muon. I'm going to show you what is in space. It's very hard, Sabine, to be respectful here at this point, because everything I hear from you is disrespect to my research.
So, multiverse research has a problem, but it's a different problem. What about Avi Loeb's claim that the interstellar object Oumuamua was alien technology?
All right, let's talk about that. It is not alien technology. It is a biological body part. Let's take a look at that, Sabine. Okay, I have discovered literally everything that I can find in space is biological. This is Comet 67P. This goes back to 2015. I had to shut down this channel because I was attacked so bad for making the statements I made. And then I decided I'll just open up Mudfossil University and I'm going to take over science, which I have. And now they are in retreat and starting to come around. Now listen to what they have to say about Comet 67P.
On Rosetta's OSIRIS instrument. They are really strange. The pits can be found clustered in just a few regions on the comet's surface. There are small groups of them on both the head and body of the rubber.
You see this? That's coming out of there. That is boiling meat. That is a smoke that comes out from meat. That is not dust blowing off of here. You see how every one of these little spots, these are all blood vessels. Yeah, I know. Oh, the guy's crazy. Well, let's see who's crazy. Let's keep playing it.
A duck-shaped comet, but nearly all of them appear in the comet's northern hemisphere.
All right, I want to just mention this. The reason for this is those circular structures are the product of tendons.
On Rosetta's OSIRIS instrument have spotted dust jets shooting out of some of the deeper depressions, but those that are more shallow do not seem to be active.
All right, the reason is the ones that are more shallow are not spitting out gases because they're not blood vessels. Those are emplacement, like what they do is they hold the tendon in the muscle so that it doesn't escape when it's being pulled against. These are little grabbers, basically, that they're all over the tendons, and that's why they don't emit.
The authors explain that these large punctures could not have been made by impacts, because they have the wrong size distribution, and you wouldn't expect to see that many impact craters on a body as small as Comet 67P.
You see this? This is where the bone comes out to end. This is the end, which is like an Achilles heel, and this is all fibrils, and I will show them to you. And this is exactly what happens on a tendon enthesis ball. It's called an enthesis, and it has all these little dimples in it so that when it's embedded in the muscle tissue or in the bone or wherever it's embedded, it will not rip out. These are anchors, basically, and that's why they don't emit gases. The deep ones that service the blood are the ones that shoot out the...
They wondered if the pits might have formed as a result of the melting of frozen materials on the comet's surface.
All right, these structures that you're seeing here, those are the patterns of... They're almost like pine cone patterns. the patterns of the pine cones on the surface of the cone. And the other holes that they're talking about, the circular straight down holes they think might be sinkholes, those are actually vascular investments, blood vessels, veins, arteries, that type of thing. Okay, this is on the Rosetta mission. This particular structure they're looking at, and he's saying, look at this, how white this is. I have the exact same thing right here. Hold on. Hold on, here it is. Well, let me just show you. I'm sure I showed it in here. And then now, look at these transitions coming down like this. Look at this specifically, and look at this flat spot. Now look at the way this planes out, and then you get. No, this is my. We get this down carefully so this can be seen. See that? That is that flat spot. Right there. Same one. Rotate it down. You see these. Oops, I can't. Let me just do this with my finger. See, this is the ball, the same ball, and there's the same stalk. You can see these are the identical same structures coming down. If you look over here, well, as a matter of fact, you can see, I'm not going to go any further, but you can see that's that, and that's that, and this is a ball in here, and well, let me just get a little further out here. All right, I guess I didn't show all of the other stuff about it in this particular. Oh yeah, here it is. This is all about it right here. This is what happens in tendons. All right, remember I showed you all those little clusters around those little ball holes? That's what this is. And then the stalk comes out, and I showed you the stalk. And let's see, what else did I show you here? So this is the way the tendons work, and these transitions break right here between. That's why I could show you that little stalk, and they break off flat as a pancake, and that is what's called a transition. Mineralized tendon. Let me come out to where I can watch this. Wait till you see this. All right, this is on 67P. We can see the muscle bundles. Listen. You have to look a little bit and think a little bit about this. You see this structure right here? It's sort of a circle with a hole in the center, and this sort of is a circle with a hole in the center. These are some form of bundles or tendons. I believe they're tendinous material, but they form these little balls. You know, they're bundles. They're pinchy bundles. I want you to look at this. Down here is Comet 67P, and I want you to look at those structures right there. You see those? All right. I'm saying this. I've had this looked at by anatomists. They understand what this is. This is a ball of fibers. Now, you see little pinchy bundles in the middle. Are these tendon fibers or muscle fibers? I'm not sure. But I believe they're tendon fibers, and they break right off where they start to begin to attach to the muscle. But I can show this. This is a tendon extreme I'm detail. Saying that these are the same as the broken fibers that I just showed you on the specimen that I have here in my shop. Now, watch this. As I back up from this specimen, all right, I'm going to back away from it, or I'm going to twist around from it, because this is amazing what happens. Now, as I move up the fibers, all of a sudden, see them? They're like little, they look like boar. You see that? These are tendons. This right here is the gluey fabric that glues the tendon to the muscle. And I've looked at this of course, in my microscope. And then all of a sudden, bang, look at that. See that? Flat as a pancake. And these are blocks that are literally little square-looking blocks of extremely hard, tendinous material that makes up your very, very hard, tough tendons in the body. They break off at this gluey spot, just as flat as a pancake. And when you find out what these things really make up, when you look at Comet 67P, that is as big as a city. That comet is as big as a city, and these are the kind of fibers you see coming out of there. The fibers that are on Comet 67P might be 500 feet across, 100 feet across, one of these fibers. They're not small. Look at that. Now, this white stuff, you see that? That's mineral. I'm going to just come way out to here. Now watch this. Further up. This is the tendon, which attaches to a bone or somewhere, one of those balls. Then it comes out to a gluey spot. The gluey spot says, okay, you're tough. You don't really stretch much, but we need to get to a muscle that can pull and do all this work. You attach to the bone. I'm going to glue you to a piece of muscle, and here's the muscle. Let's see what happens now. It says, okay, what are we going to do from the tendons? We have to make a transition into the muscle. Now, where do you see this? You see this right here? Look really carefully. You see that circle? You see this curve? This is muscle. It weaves itself right into the glue. It really weaves itself into the glue. And then we start to see this white mineralized stuff, which is tough. That's the tough stuff. And eventually when you get into the muscle, no more and here white. Here comes the muscle. Isn't that something? There's a muscle. And so you can have another sort of... See that little curve right on? There's a muscle fiber. The black and the white, or, you know. Whenever you see that, that's mineralized. That's a little tough. That's tough stuff. And then you get into these abrupt transitions. Brown, white, like this is an abrupt transition right here. Now, I'm going to home in on this a little better if I can. Now, you still see minerals in there and things, but it takes on this band of fibers, and they weave into each. These are the loose connective tissue, and then embedded in a loose connective tissue is your flesh, which they call sarcomeres. They're the little pinchy parts that make your muscle work. Each other, and they still get service with blood here and there. You see that right there? That's an abrupt transition. You see it? They break right off in these abrupt transitions as they go further and further out, they become more and more muscular and more. This like I think there's about 4 or 5 transitions I found. And off that way, and it broke off on this end. And of course, that's the end where the end transition is. So we've seen Comet 67P. It is biological. It has the same exact tendons. There's no difference whatsoever between that. Well, let's just, there's the tendons right there. There they are on 67P. These are the tendon fibers right there. They break off, just like I showed you. There's abrupt transitions. This is a bundle of fibers that is either the muscular bundle. I think that's a bundle of muscles that come up right next to the tendon, and they link up above. I think this was from a foot. It appears to me, but it's no question it's biological. And the gases that were given off, the spectral analysis is 100% biology. I studied the whole thing. They had Kenneth and Juliet were the particles that they tested for their atomic molecular signature, and it was all biology. It was all iron oxides and silicon and all of the things that are in your body, exactly identical, no difference whatsoever. And they had no way to speak about it, so they just stopped talking about it. And then she's talking about, oh, this guy's making these crazy claims about this thing might be an alien aircraft or something. Well, that's not so crazy. We know that now that there's aliens and UFOs. They had to get here from somewhere. Either they were here and living here and they're in the ocean or under the, somewhere down in the earth, or they came from somewhere. So why is that an insane speculation? It's not correct. I agree. It's not an alien spacecraft, and I'll show you what it is. It's a finger. Okay, I'm going to say that is a finger, and I have shown this to anatomists. They understand. That's the bendable joint in the finger. These are all the little tendon fibrils that come up to a circular thing up at the top, which is called an apical tuft. They sit right there, and all these little strings attaching to these balls. There's still one ball left, and they all have strings coming down. That is the place that this sits right there, is exactly where it sits. Now, they come back and these strings attach to here, which is the joint of the finger. Then you come down here to the next attachment. That is the blood on one side, that's blood on the other, and that is the bone coming up. That is a finger. And I showed this to one of the top anatomists in the world, and he said, it's the fingeriest finger I have ever seen. So, and that was my friend Gil Headley, who is an extremely excellent autopsy analyst and has been doing this for many years. I hooked up with him 10 years ago, and he basically verifies the things that I say either are right or are wrong. But so far, the things I have said, he hasn't been able to come up with any reason that I'm wrong. You know, he's not saying I'm 100% correct every time, but he's saying that is the anatomical effect of a human finger. Right down, it's broken off right down at where these tendons would invest. That's the bending part. That's the apical tuft. That's the tip of the finger. This is literally grip skin. Grip skin is not normally like the lower skin. This is grip skin. And this is that attachment right there, which is the apical tuft. Now, I have a fingertip that has grip skin still attached to it, and it's gigantic. It's absolutely enormous. It's 3 feet long, the fingertip. And my fingertip is only the very end of the fingertip. Like this has a bone, I'm not sure where, I believe there's a bone in here, and it attaches. So you have, not only, this is right, the knuckle. All right, this would be the knuckle. So you have another bone up here, right in here, that attaches to the tip of the finger. And that's what a molar is. And if you talk to any anatomist and have them look at that very carefully and look at these spots where the tendons lock in and how the fibers are broken off and how the fibers come around and how the blood supply supplied both sides. One is dark and one is white. And that's exactly what happens on all of them. Like this one here, you see, I dug around in this, but this one here, there's the dark side, the black side, and that's the blood side, which gives you, the black one usually is the vein. The artery is usually a white, reddish one. But the black one usually seals right off at the surface and turns black because there's no return. I mean, there's no give and take with the veins. The veins clamp off. When you die, the black blood, which it turns black in mud fossils, it just seals right off at the surface. So I dug that out of there. But when I first took it, it was just black as black could be, and that was white and reddish. And if I put water on here, if I put water on this right now, watch this. I could make that thing turn red in almost instantly. See that? That's blood. There's a layer of blood tissue that runs up underneath the layers of tendinous material and so forth. And they're fed with blood, just like everything is. That's a mud fossil. And here's the tendon emplacements right here. You see how gnarly looking those things are? You see it? The gnarly looking things. Those are the balls, the tendon balls that I showed you before. This thing's all eroded out, and I broke it off and cut it and looked into it and all that. But that is literally blood. And I can guarantee you right now that you could find DNA in that blood. Everything I have here, I have 3 DNA tests on my stuff, so I'm not just blowing smoke here. And the stuff that I have is enormous, and it's DNA certified. There's another bone. Blood just came out of here. It literally had a scab. Well, let me show you. Because today I'm done playing games with people. I want them to pay attention to the real research that's being done instead of doing what Sabine does. Say, "Oh, don't pay attention to that. It's just wasting your time." No, it's not wasting your time. You're learning something. This is not just nonsense. See, that's a bone head. That is the head of a bone. There is no anatomist on the face of the planet that can deny that. That's where the marrow is. This is the surface of the bone. They call this, I believe, the periosteum, which is a coating that coats all bones in your body. And this blood came out of one of these bone foramen. And it is blood. It's not just looking like that for no reason. And here's the scab backing. I removed the scab from what's called fibrin, which is, this is what is issued by your body to create clotting so that your blood cells will collect in there and clot. And here's where the blood came out of, these two holes right here. These are bone foramen holes. That's the vein, that's the artery. The artery has the red looking blood, and the vein has the black blood. You see the black stuff coming out there. Normally it doesn't come out, it sort of seals off. So anyway, that just shows you that there's no question we have blood coming out of rocks. You can't get a rock without blood. You want to see some blood? Here, I'll show you some blood. Here's some lungs, and this was DNA certified. That one here was a DNA certified human. All right, this one here was stripped off of all the pleura down to the alveoli, and it literally leaked blood all over my counter. I'm not kidding you. You take them out of the mud. When they're encapsulated in the mud, they're sealed. And if the mud is at the correct pH, they don't even know they're dead. A lot of the membranes, see, I was going to call this fascia-facilitated fossilization, because this is what's called fascia. It coats your organs, it coats your bones, all right, it coats your skin is a fascia-type material, it coats all your organs, and they separate from the rest of the body. The rest of the body becomes mud, literally mud. Flesh turns into mud. And the rest is clay, and it was clay and mud and so forth. And the rest is your organs, and they call it marl, and it's a stony material rather than the mud, because there's all kinds of transition metals in here that turn into rocks and things. And I have a million of them. I mean, I got so much stuff that we'd be here for years talking about it. However, this is no question, this is a lung. I mean, there's nobody can deny these things. All they can do is say, oh, it's impossible, and walk away like Sabine. So I don't want to waste my time on this. Well, we're not wasting time. We're learning. We're investigating. But I agree, if there's nothing to look at, well, then that's a different story. But I have everything to look at, and it's being dismissed and being denigrated by people like Sabine for showing the evidence that I show, and then they, instead of investigating it, they walk away and say, no, this guy's got to be crazy. This is just insane stuff. It's just too much for us to, because she said a lot of things. This is impossible, so why even bother? No, nothing is impossible if you can present the evidence. I presented the evidence. Therefore, not impossible. Okay. As I showed you, the things that are in space, I'm saying are body parts, and body parts contain blood, and blood is basically composed of transition metals which turn into, like, metallic odor when they burn from the sun's rays. Astronauts confirm space has a kind of strange odor, metallic odor, in a video from astronaut Chris Hadfield. Confirms space and does indeed smell like gunpowder and burnt steak. All right, now let's go back to Sabine and see what she has to say about aliens, which we know there's aliens. I mean, or there's something going on. Well, as a matter of fact, let me just show you something. That I don't know what you got to think of this, but let me just show you what somebody sent me. Now, don't forget, I discovered mud fossils. I was the first one in the world to have ancient DNA done on giant human beings, and human beings from the past of any sort. And they turned out to be human. I've been getting things from all over the world from people that send me the crazy things they found nobody will look at because they're just too much to handle. This is areolar tissue. This is interstitium. This was alive, this creature, almost unquestionable that it was alive at one point. And every one of these things that I can see, when the people work with me, I can find the blood vessels. I know how to look for things in these different creatures now because I understand how to find the blood vessels and all of the anatomical features that prove what I am asserting. And this is interstitium. That is these little pockets that I don't know if I showed you yet, but they have really just been discovered, and they have just been discovered because of my work, because I can find these in my ancient specimens, all these pockets of interstitium, and they just discovered this as a new body organ. So, Sabine, you have to look at what is, you can't just throw things in the trash. All right, I was the one that discovered this, not scientists. Scientists say they discovered a new human organ, fluid and tissues connecting them, all called interstitium. And they've found throughout the body, both just below the skin and in the digestive system, respiratory, urinary system, they coat everything. Every single organ is coated with interstitium. Underneath your skin here is a bazillion layers of those fluid-filled bags. I just showed you on an alien head. I discovered this 10 years ago, and I worked with Gil Hedley, who was one of the top anatomists in the world, and we really went into this deep, and because I could see the things, just like I showed you in that alien head. I said, what are all these pockets and these holes? He said, oh, we used to call those fuzz. And then we went on from there. Now it's considered one of the most important organs in the body because that's where your immune system lives. These are your membranes, and they house the bacteria. So this is not just silly research, Sabine. This is the problem with the elitist scientists. I was just given a week suspension off of YouTube for posting this about the National Institute of Health. This is not my words. National Institute of Health, National Library of Medicine. Probiotics in the prevention and treatment of COVID-19. I posted this and they knocked me off for a whole week, gave me a strike, which is totally wrong because they're not allowing this information to get to the people. 2021, March 19th, just a couple of months ago. This, from what they're saying, I'm not going to make any statements whatsoever about this, but if you read what the conclusion is, let's just read what the conclusion is, because I got a week and a strike for saying this, and I'll probably get it again. I don't know, but I'm getting kind of upset about people like Sabine and all of these elitist people that say, don't look at this, don't look at that, because it's just nonsense. Well, look at this. Evidence supports probiotics' role in regulating the immune system, suggesting a definitive, absolute, no questions whatsoever role for probiotics in viral infections, which is this what we're doing. Probiotic supplementation could reduce the severity of COVID-19 morbidity and mortality. Reduce it. That's not my words, their words. Probiotics can inhibit cytokine storms, stop the cytokine storms, which destroy all the organs in your body, by simultaneously, at the exact same time they're stopping the cytokine storm, they boost the innate immune system, evading the time it takes to adapt your immunity, so you can respond quickly, basically. Probiotics induce suppression. They suppress the inflammatory response from the cytokines, and they prevent the severity and occurrence of acute respiratory distress. I didn't make this up, but they're not doing any random control tests. So therefore, we can't say that it does anything. But they say all that stuff, but they're not doing any tests. Why? This is what I want to know, because it's elitist science now. If you're not a member of the pack and you give the orders, you take the orders. Now, I like Sabine's attitude, but if she'll address me, I will have extreme respect for her. But if she doesn't respect or address me, that respect is not going to be there. I mean, how can you respect somebody that says the things she says and wouldn't address me? Now, I've tried to contact her. I haven't gotten any response. So this is my response. Okay, so back to Sabine. Now, and I do want to be respectful. Everybody wants to present their points, and I do too. But when my points are factual and evidential and material and not allowed, that's when I get upset. And I can feel I'm getting upset after 10 years of this denial by people like Sabine and people that have the stage and suppress evidence. That's where I get upset. And when she says, oh, throw it out, it's unscientific, it's all that, I just showed you that if I hadn't paid attention to the things I paid attention to, none of this would be known. And all the things I'm presenting, if she can say they're wrong, I want to hear from you, Sabine. And I could be respectful. We can talk very nicely. We can have a nice Zoom meeting, a debate, and say, you can tell me, why are you saying this? How can you present, what evidence do you have to support that? And I will respond with my evidence and my comments. And if I'm wrong, I'm wrong. If I'm right, I'm right.
Isn't degenerative science, and it isn't unscientific either. It's just bad science. He jumped to conclusions that simply aren't supported by the data.
All right. She says he jumped to conclusions. Now, did he say it's absolutely a foreign ancient, UFO? I don't know what he said. But until you investigate, there is no conclusion.
Data. It isn't hard to guess that many physicists would object to my assessments, and that's fine. My intention is not so much to argue this particular assessment is correct, but that such an assessment must be done regularly in collaboration between physicists and philosophers.
And anyone that can present evidence, not between PhD this guy and PhD that guy and nobody else counts. No, I don't have any PhDs. I didn't care. I have more education, I'm absolutely certain, than you do, sweetie. So don't tell me that because I'm not part of your network, I can't speak. I want to be heard.
That was in my opinion piece for the American Physical Society. I actually think I was being very polite. But the second editor...
Well, of course you're being polite. You can be polite and be completely wrong. That's nice. Everybody likes polite people. But when you refuse to engage in a conversation because you are wrong, politeness has no place in that. The engagement of scientific discussion automatically creates some kind of conflict. I mean, it's just obvious. You're going to have one point, I have another point. If you push back against my point, I will push back against your point. But if I have the evidence to support my point, and then you just say, no, it's just wasted my time, then that's where I get upset. Obviously. 10 years of this nonsense, obviously I'm upset.
Finally decided that when they asked for an opinion, they did not want to hear an opinion critical of the community.
Exactly.
The obvious ignoring criticism is exactly how groupthink happens.
Oh, now we are on the same page.
And this episode is a demonstration of just how it happens in physics. The point of my piece was to say scientists need to regularly assess whether their research methodology is progressive.
Yes, Sabine. Let's address your research methodology. To just dismiss things because you think they're impossible, which is the things you've said before. Oh, that's just impossible, so, obviously we're not going to look into that. And I don't mean to be disrespectful again, but I really expect to hear from you, Sabine. And I want everybody on my channel to go to her channel, to her Facebook, to all of these places that she's making these statements and say, please talk to Roger. Address his comments. I will present my proof, you present your proof, and then we'll go from there.
The APS decided to not even ask physicists to think about what they're doing. For the spoken text in this video, I slightly modified the text I'd written for the opinion piece.
Well, there's no reason to go any further. I want to hear from you, Sabine. I have the evidence to support my side. Now, I'm going to make one final conclusive, statement about what I have presented and what I expect to be spoken to about because of the things that you said. Not because of any other reason, but you made those statements. You said that this is really physics. These are scientists. We have to be scientific. We have to investigate. We have to look back and make sure our methods are correct. We have to reassess what we're doing and be sure that we're not wasting our time. Yeah, absolutely. I'm not about wasting time either. But when I follow something, I follow it. I don't just stop and say that's impossible, case is closed. Never. Okay, I'm going to sort of wrap this up now, but it's not just Sabine, it's all of the PhD type, real hero-looking people that you see representing CERN and Fermilab and so forth. Don Lincoln and Kirsty Duffy. I've tried to get them to take a look at this forever. I have created the Muon, and I have created electron showers. If they won't engage, what can I say? And then I saw Don Lincoln acting like a drunk robot, saying there's a crazy guy talking about he can accelerate light and do all this stuff. He's crazy. And then Christy Duffy came on, who is also a Fermi Lab representative, our government, and came on and says, if anybody says they can show you a muon, they're a liar. Well, Kirsty, I could show you a muon. I don't think I'm a liar. I try not to lie. If you think I'm lying, well, show me I'm lying. See, here's the curator in charge of invertebrate paleontology, Yale Museum, refuses to even look at anything that I have presented. Derek Briggs from Yale University, I've been trying for 10 years to get him to look at my stuff, refuses. And therefore, nobody else will look at it because I'm right down the street from Yale, literally. I'm only 20 miles away. My stuff is right down in their backyard, and they refuse to investigate it. And he's told me that everything I have is just rocks, regardless of the DNA, regardless of the CAT scans, regardless of specimens, without any observation whatsoever. Now, these are the kind of people that I want to fight back against, and I see that as a fiduciary failure to students. So that's just another issue. If I was a student, I would call him on this right now. But, because that's really destroyed my research for 10 years. So now let's get past him and get back to Kirsty. I got so many of them that, what's her name? Sabine, hold on. All right, here's the problem with Derek Briggs and Yale and all the rest of them. I tried everybody, literally every university I tried, and nobody would get involved, nobody would respond, basically, because I have the DNA evidence from back in 6 years ago to support exactly what I'm saying, and these were the results, that they were Homo sapien, mitochondrial, B gene and D loop region on both the lung and 36-inch sample. Very dense DNA. Excellent quality DNA was obtained from the 36-inch sample and the lung using these primers. Now, that was a 3-foot long fingertip. And that's, the things I'm showing are spectacular, absolutely. And they are scary to these people, and they are really invasive to their way of life, dominating the students with things that just aren't true anymore. And they know they're not true. So I find it very difficult to allow this to continue, because this was a verified test. That's the lab director, Helix Biolabs, and he said he stands by the test. Now, I took the samples, and if you can find that I did it wrong, then you prove it, and I'll back down. But if I'm not backing down, because I have the physical evidence in my hands. This had dense DNA. That's the fingernail. That's the bumper pad on the back of the finger. And I broke off the fingerprints, which are what they call grip skin. And there it is right there. That one finger ridge print is the same size as my thumb. And this is what grip skin is. And I showed that a Muon. That's what the grip skin is on the fingertip of a Muon. That's sticking out just like that, and you could see the edge of it all broken out, because it peels off just like that. This just peeled right off. I smashed it with a hammer, kind of a sledgehammer, and it popped right off. And there was the fingerprints. And then I went up inside the finger and took out the blood. And this blood in here, I can take blood right out of there right now, no question whatsoever. And I can have it tested, and it will come back as whatever it is. You want to test it? Come on down. There's another one that was on that same thing. It's a left hand. The bumper pad is right here, just like yours. There's the tendon that runs down. Just look at these things carefully. This is the grip skin. Remember we talked about the grip skin? You have grip skin on your fingertips, your toes, and the pads of your feet and your hands and everything. But it stops as it comes up to this bumper pad. Now, this is one of the fingertips. I have knuckles, I have the toes, I have all kinds of things from this guy. And that's 3 feet wide. And that was on that test as well. That was the third thing that was on the test. And then there was a lung, and the lung is the size of us. I think I showed you that, and the blood comes out of it. You can't get a rock without blood, as far as I'm concerned. I know that was just a silly statement, because obviously there's sedimentary rocks here and there. But a lot of the sedimentary rocks they think are sediment is not sediment. It is tissue layers. And I've shown that quite well as well. You see that? That's muscle in a mountain. We're talking about things that nobody's mind can get their mind around. This didn't flash this way and splash this way and add more sediments and this and that. That is connective tissue and red flesh that's mostly eroded away, so we're seeing mostly the connective tissue. This is one that is in my shop. They're right in my shop. It's the same thing. That's a muscle. That's muscle from, I believe it's a shoulder. Up here, there's a big round thing up at the top where I believe a shoulder or something. And then that's the tendon, and then it runs into the muscle. And these are the muscle bundles breaking off. As I told you, I showed you before. They have abrupt transition. This is the blood that fed this whole operation here. I have the things to support the things I'm saying. And now I was the first one in the world, literally the first one in the world that I know of, unless you can support some other one that did it before me, had the DNA test done. And nobody else would do it, and they still won't do it now. And because everybody's afraid of being attacked by the academics because of showing things that they don't want to have seen. Because I can't find anybody to do any more DNA tests. I tried yesterday a big lab, and they, oh, no, we can't do any of that stuff. You see that? That's an abrupt transition right down there. These, you know, I understand these things very, very well now. You know, after 10 years of working with them, microscopes, chemistry, anatomists, the chemistry is the big thing, because I've discovered the process. The process is nucleophilic substitution, which means in salty, wet waters, the invasive chemicals will come in and stabilize with the unstable biology, which is always unstable. You're always unstable because you're giving and taking and giving up particles and taking in particles. See, another abrupt transition right there. Anyway, I think I've shown this enough. I don't want to bore people, but we need to get this known and start to discover our real world. That's all. Just let's explore. That's all I'm asking. But it's a denialist society now, and that is to protect the people that have invested their lives in a certain position, and now they feel like they're in trouble. They're not in trouble. They just need to have to say, wow, I know a lot about this, but I never took it from this angle. Let's look at it from this new approach. That's all I'm asking. Examine it. Then walk away, laugh and say, oh, the guy's crazy because I can see that's not muscle. I can see, I can prove chemistry is this and that. Well, I can prove all the things I'm saying. I'm literally 100% certain of every word that I have said. And if you can dispute any word that I have said about any of the things I've shown, I want that confrontation. That is what I'm asking for. And then we can debate it. That's all I've ever asked for. All right, I know I showed this before. We know we can split the actual photons of light and create, I believe, free energy. This I can't prove without having somebody make a harvest plate back here and do this where we can circulate that energy into a storage device. But I can tell you what, Einstein was absolutely wrong about the things he was saying, because light is a particle and a wave because it's got a magnetic field. It's like a balloon going through with a center spot. Light can be accelerated, so boom, sorry Albert, not correct. We can split light, we can accelerate light, we can create the Higgs fields, we can see the photons, we can see dark matter now. And this here, this is one I didn't show you yet, but that's a Higgs field colliding with an antiparticle, I believe. We have a lot to examine. I have the evidence been ignored for years and years and years, and now I want it seen. It's just time to make things right. And that's all I'm asking for. Make things right. If you claim to be a scientific person and looking for the answers to the situations that we are confronted with, and the only way you're going to be able to confront these problems we have is scientifically, and I believe I am showing the scientific evidence that trumps everybody else. I don't want to use that word because that's a pretty explosive word, but I believe my evidence exceeds anyone else's evidence at this point. And if I can be shot down, that's fine. I'm glad with that. But I need to have that confrontation.